Hello students, here is a question. The bullet of mass 0.1 kg is fired onto a wooden block to pierce through it, but it stops after moving a distance of 50 centimeters. If the velocity of the bullet after hitting the before hitting the wood is 10 meters per second and it slows down with a uniform deceleration, then the magnitude of effective retarding force on the bullet is x newton. The value of x2 is nearly to b. So here there are two things to be taken into importance, that is the velocity of the bullet before hitting the wood is 10 meter per second, because after it penetrates through the wood it travels a distance of 50 centimeter and its final velocity becomes 0, so it stops. But we have to say take into the term for that is of second and most important, that is it slows down with a uniform deceleration. So at uniform meaning the a in that case was same throughout. So here what we can say is the A was constant throughout these 50 centimeters, and using that logic we can use the third equation of motion, which gives us a relation between V, U, A and the distance traveled, which is V square minus U square is equals to 2AS, where V is the final, U is initial velocity, 2 is the constant, A is the acceleration that we need to find, and S is the distance traveled. Now here V square is 0 or V is 0, U square is 100 or U is 10, 2 into the acceleration. We are told that acceleration is retarding and it is uniform deceleration, meaning the acceleration is acting in the opposite direction with respect to the velocity. So acceleration is taken to be negative. The distance is 50 centimeters or 0.5 meters. Once we put in the values, we get the value of A to be equal to 100 meter per second square. And the retarding force is mass into acceleration, which is mass into acceleration 0.1 into 100, which becomes 10 Newton. X is 10. Thank you.